Welcome! Today we'll solve the integral of 1 over x dx using two different methods, the standard method and the series expansion method. Let's start with the standard method. We know that the derivative of the natural log of absolute x with respect to x equals 1 over x. Let's visualize this relationship. Here's the graph of y equals 1 over x, and here's the graph of the derivative of natural log of absolute x. Therefore, by the fundamental theorem of calculus, the integral of 1 over x dx must equal the natural log of absolute x plus c. Why do we need the absolute value? The natural log is only defined for positive numbers, but our integrand 1 over x is defined for both positive and negative x except at 0. The absolute value ensures our result works for both positive and negative x. Now let's solve this using the series method. First, we can express 1 over x as a series using the binomial expansion when x is near 1. When we integrate this series term by term, we get x plus x minus 1 squared over 2 plus x minus 1 cubed over 3, and so on. This series is actually the Taylor series for the natural log of absolute x plus a constant. Therefore, both methods give us the same result. The integral of 1 over x dx equals the natural log of absolute x plus c. This is a fundamental result in calculus that you'll use frequently in more advanced problems. Thank you for watching.